Hey everybody, welcome back to Young Engineers of Today. We're going to spend some time continuing with Python, just until we get a more concrete idea of what we're going to be doing in the coming weeks. So, with that in mind, since going through CodeCombat along with you guys seemed to be a big hit on Monday, I'm going to continue to do that today. We're going to start up again where we left off on Monday, and we'll work from there. We'll make some more progress, learn some more stuff, and then we will hopefully, from it all, gain a better understanding of Python. All right then. So, why don't you guys go ahead and head back on over to CodeCombat and get logged in. I'll give you guys a moment to do that. In the meantime, I'm going to go ahead and click play. So, one of the things that's nice about CodeCombat, if you haven't used it before, if you have, well then you know what you're dealing with, although they have added new things. Well, one of the things that's nice about it is the different worlds are divided up with different sort of paradigms in mind, I guess. Kithgard Dungeon, the first world, is all about the syntax, as well as learning about variables and methods, parameters, passing things, returning things, sort of communication between methods. Backwards Forest is about control structures, so if-else, and relational operators, less than, greater than, equal to, stuff like that, object properties, whether or not, if you think back to our car example, what color the car is, that kind of a thing. Input handling, so taking input from a user and acting appropriately. Then you've got the desert, which is arithmetic or arithmetic, depending on your pronunciation. Counters. So arithmetic and counters are actually the basis for while and for loops, which they introduce while loops here. I believe they have for loops in the forest also, if I remember correctly, although that's entirely possible that I'm not remembering it correctly. But anyway, break, arrays, string comparison, and finding a minimum and maximum. Mountain isn't really done yet, but like entirely. But it's all about, well, object literals is goes by a few different names, but it's basically static objects and things like that. You've got remote method invocation, so relying on a secondary method in order to start another one. For loops. It's really strange how they have for loops listed there, because I really am remembering for loops being in Backwards Forest, but I could be wrong. They could have moved things around, or I could just be remembering it incorrectly. Anyway, functions, drawing, and modulo. Modulo is fun, sort of. I mean, I guess it depends on your definition of fun. Modulo is just a fancy word for remainder. So, for instance, 6 modulo 4 is going to be 2, because 6 divided by 4 is equal to 1 with a remainder of 2. Likewise, 3, nope, let's do 5 modulo 4 is going to be 1, because 5 divided, because 5 divided by 4 is 1 remainder 1. So you get where I'm going with this. 100 modulo, why did I pick that one? Let's go 20 modulo 3 is equal to 2, because 20 divided by 3 is equal to 6 remainder 2. You get the idea. It gives you the remainder of a division operation, which is handy for a lot of different situations. Dice rolling, trying to find a margin, calculating error, things like that. You can turn a random number generator into something useful by constraining it within a certain range, because a lot of times random number generators will give you a number from negative 65,000 to positive 65,000 or whatever. Um, this will allow you to constrain it within certain things, because if you do like modulo 100, then your answer is going to be somewhere between 0 and 99 included. So it could be 0, it could be 99, and it could be any of those in between. Because obviously you can't get a remainder of 100 if you're dividing something by 100, because that would just be another 100 you could divide into it. You get what I'm trying to say, although I'm not saying it particularly well right now, and I apologize. Anyway, we'll jump right into Kithgard Dungeon and continue along with what we were doing before. For those of you who need a refresher or weren't here on Monday, we basically spent some time talking about some of the concepts behind CodeCombat in Python. So we talked about the self keyword. The self keyword refers to an instance of an object. In fact, itself. Wow, that crossing the T there got a little intense. The example I used was if you call a function inside of a class that's also inside of that class, you can use the self keyword in order to tell the computer that it is inside of the same class. So that was the self keyword. We also talked about the access modifier, the period, which basically, if we did like a move right, which was the example in the very first, well, and actually several of the levels, move right is a function inside of a class. So we're saying with... No, sorry, Ben. The Pi lessons are being postponed for a little while, just because of some issues. They're they will happen. It's just not going to be today. Yeah, I appreciate it. Anyway, the period means that it is inside of a class. So if we had like car1 dot color, well, what we're saying right here to the computer is there is a color variable inside of car1. And that's what this period means right here, is it means that this is inside of car1. This is the what, and this is the who has it. So we went over the access modifier. In addition, we also spent some time going over how to tell whether or not something is a function, and that was really simple. That was the parentheses. So if you have a word or, something like this where it's like a compound word, it's a bunch of words all smashed together with no spaces, and you have parentheses at the end, open and close parentheses, you know it's going to be a method which is a set of instructions. So like the honk horn method, we know it's a method because it's got parentheses. And then, you've got instructions like print, beep, stuff like that. In which anytime you start up honk horn, it will run this instruction, it'll run any subsequent instructions, and then it'll go back to who called it. Arrows. Arrows everywhere. I go crazy with the arrows. We also went into the reason why those parentheses exist with parameters. And the example I used was add. So again, we have add, and we have something like z equals x plus y. So we know z is a variable. Z got declared here. X and y may have been declared here, but that gives us a problem. We don't know what x and y are. We just don't know. We just declared them. They could be filled with nothing. They could be filled with garbage. Garbage meaning, fun fact, when your computer uses memory for stuff, it fills that memory up with information. When it's done with that information, when it's done with that memory, like let's say you start up a game and you play the game for a while and then you close the game and it frees up that memory, it doesn't actually empty it out. It just says, okay, those blocks of memory, fair game for anything else. They're still filled with whatever information was last put into them. So, in this sense, this x right here, the block of memory that holds that x, could have been previously filled with, I don't know, part of an instruction on how to draw a cat. Or it could have been filled, with the word balloon. Or it could have been filled with 165,352, or whatever. Its point being, there could be literally anything in that slot of memory. Because it's probably been used at least once since you've turned on your computer. Probably. Depends on how long your computer's been on, depends on what you've been running on it, but probably. So, this is all true because we haven't actually put anything in x and y yet, so we need to put something in x and y. But how can we do that without declaring variables in here? Well, we can add parameters inside the parentheses. So now we've got x and y in here, and of course they match up with these. So that is to say, if you called them x and y up here, if you want to use them throughout your method, you have to call them x and y in your method. Outside of your method, you can call them whatever you want, but inside your method, you have to call them x and y, because you're declaring variables here. You're also initializing those variables. How? I'm glad you asked. So let's say in your code, let's just go ahead and get rid of our thing over here. Let's say in your code you call add. And you go, yeah, alright, cool. And computer doesn't know what you're talking about. Well, that's a problem, but it's fixable. Basically, if you were to run this method in your code at all, you would have to set it up so it has the same format. So in this instance, we can feed values into it. So we can go 5, 3. Notice how it's separated by a comma. Notice how they're in the parentheses. Notice how it's separated by a comma. Notice how they're in the parentheses. I think you get the idea. The 5 gets fed into the x, and the 3 gets fed into the y. So now, when add is running, x is going to have a 5 in it, and y is going to have a 3 in it. Suddenly this makes sense. Z is equal to x plus y, z is equal to 5 plus 3. 8. Now the computer can do math, which is, all it's ever wanted to do all its entire life. And you've just helped fulfill a computer's dream, yet again. You should feel good about yourself. Likewise, if we called add again and fed it different values, 6 and 4, well, add would open up again, x would get populated with 6 and y would get populated with 4, and then it would go through the addition, so it would become 6 plus 4 equals 10. Once again, computer's happy, everything's great. Now, you can even take this to the next level. Let's say we had a variable called a, and we set it equal to 3, and we had a variable called b, and we set it equal to 9. Well, you can go like this. Boom. So now it's taking the contents of a, and it's dumping them into x. So it's taking 3, and it's putting it into x. A is still going to have 3, it's just the computer doesn't really know about that right now. It gets into things like variable scope, which, you worry about later as you get more into coding. B has the value 9 in it. The 9 gets dumped into the y. So now you've got 3 and 9, and it does math with those. Adds them together, comes out with 12. Everybody's happy. So parameters are a vital component of functions talking to one another. They allow a function to send information, or a method, to send information to another method, even though they're separate from each other. So that's one of the parts of object-oriented programming. So, here you go. Let's say you've got your main, and you've got add. Boom. Sending 3 and 9 over to add. That's one part of the communication. We also spent a little bit of time talking about loops. Loops allow you to, loop bits of code. The loops that we were looking at were infinite loops, or forever loops. That is to say, they ran forever, or they ran infinitely. The reason I, kind of mention both of them is mostly because uh, personal preference. Infinite loops, in my mind, tend to have a connotation of unintentional. So an infinite loop is when you try to make a loop that ends at a certain point and you accidentally botch the code so that the loop runs forever. Instead of, maybe like 7 times, it runs for now until the end of eternity, which is not really a thing, so that should give you an idea of how long it runs for. A forever loop, on the other hand, a forever loop was one you meant to make forever. This is an instance of a forever loop. It just says loop, and then we have 4 commands in it, and as soon as it gets to the last command, it comes back around to the top. And that's really all a loop is. Otherwise, let's say we wanted this to run 3 times, we'd have to copy-paste this code, or type it out, God forbid, 3 times. So we'd start going like, oh, okay, self dot move right, self dot move right, self dot move up, self dot move up, and so on and so forth, and that just becomes way too much work. So we do it once, we set it up in the loop, boom, we're done. The computer handles everything else from there on out for us. Let's see here. Yes. That brings us next to master of names. I know I skipped a couple in order to get there, but master of names introduces, wait for it, yet another important part of programming. Well, what is that, you might ask? I'm glad you asked, I might say, and then click play, and wait for it to load. Okay, what is going on here? Well, other than the rampant stabbing happening over here on the left-hand side. I mean more the code over here. Okay, so we've got variables. That's nothing new. Enemy 1, enemy 2, enemy 3. If you think back to our math example, this is the same deal as our AB. These are just 2 variables that have values in them, and they're being fed to a function. So enemy 3 is being fed to attack. Enemy 2 is being fed to attack. Enemy 1 is being fed to attack, and whatever the contents of enemy 1, enemy 2, and enemy 3 are, respectively, are then being used in the attack method. So far, so good, right? But how are we getting that information into enemy 1, enemy 2, and enemy 3? Usually in the past, we typed in a value, like we go like Zgrabok, and that would be, the name we type in there. That's a terrible name. And enemy 1 would be populated with the values as Grabok, and then we could feed it into attack, and it would attack an enemy called Grabok. But here they're doing something different. They're filling it with a function call, or a method call, depending on your preferred nomenclature. Methods and functions are essentially the same thing, so sometimes you'll hear me use those terms interchangeably. I apologize. Old habits die hard. I've called them functions forever, and there are so many places that call them methods. So you might see something referred to as methods, you might see something referred to as functions. They're, for all intents and purposes, the same thing. So anyway, enemy 1 is being filled with a function call. That doesn't really make much sense. No, does it? How do you, what? It's like saying, car1.color equals car1.honkhorn. That doesn't really make any sense, but it can, and I'll show you exactly how. Well, at least from, the back-end standpoint. You ready for this? This is going to be crazy. Done. One line of code. It's called the return function, a return command. And it is exactly as advertised. It takes the value of this variable, in this case z, and it sends it back to whoever calls it. So let's say, okay, so let's say we've got answer here, and we set it equal to add AB. So we've got A equals 3, right? Then we got B equals 9. So that's what's going on here. Let's actually break this down step by step. I'll scroll down a little bit. So step 1, we're just looking at basically this line of code right here. Step 1 is the variable answer is created. Space and memory is reserved for it, and this nice, shiny new variable begins its life. Look at it, how shiny. I think I can fit in more shine lines. Alright, now that starts to look weird, maybe like smelly. There we go. And there we go. Perfect. That is the shiniest variable you've ever seen in your life. Anyway, that's step 1. This variable is created. Step 2 is the computer goes, oh, this should be equal to something. Okay, let's go ahead and see what it's equal to, which is step 3. It goes, oh, add, huh? Well then, guess we got a function call. Let's go ahead and start up add, which is exactly what it does. Let me just give myself a little bit more space. I really wish there was an easier way to do that. Okay, that should be plenty. So add gets opened up. Boom, we've got add. And it goes, hey man, you got an x and a y for me? And it goes, why yes, I do. I've got an a and a b. So this is 4, and that was 5. These values get fed in. And it goes, oh, okay, cool. Okay, I can work with that. And it goes, okay, so let's create a z. Boom, boom. Step 6. And it goes, okay, z is going to be equal to x plus y. Step 7, right there. Boom. And it goes, all right, so now we know that a is 3 and b is 9, so z has to be 12, right? Cool. We've done the math. Everything's cool. Return z. Step 8. And then the value in z basically replaces all of this right here. So this can all be compressed to 12. Answer equals 12. So then the value 12 gets fed into the answer, and that is step 9. All of that to throw an answer into step 9. However, on the other hand, now communication between methods is two-way. I mean, what good is a one-way phone, right? You could just yell at your friend constantly, but they couldn't hear anything, or if you just had a friend who could yell at you constantly, but you couldn't say anything back. It's useful in some situations, like maybe they just want to say, hey, meet me out by the tree, you know, so we can, no idea, trade Pokemon cards or whatever, or magic cards or whatever. But what if you couldn't say back like, hey, I can't because I accidentally locked myself in my room? Maybe you wouldn't want to say that, but what if you needed to so that your friend wasn't stuck out there waiting for you? Well, communication in the other direction is pretty useful too, which is why that return function, return command, was created, was to do exactly that. So now we can send information into a function and have it send it back. So you can think of this as like a little factory that makes stuff. Here it is doing its little factory thing. It's the add factory. Or we feed it in numbers and we get bigger numbers out. Another way to look at it is you feed in, like a regular factory, you feed in raw materials like here's a log, and here's a stone, don't judge me, and then you get logs with stones attached to them. Or perhaps something more useful. Let's pretend that's a hammer. Cool. Alright. So now we can create these functions that just sort of do one thing, but they communicate with everything else. Upshot of this whole thing is enemy 1 gets its information from self.find nearest enemy, feeds it directly into self.attack. What's the value of enemy 1? I'll give you a hint. We don't know. We never actually see it. And that's the beauty of it. We don't have to know. The computer does all of that work for us. We do not have to know enemy 1's name. Computer finds the enemy name for us, and then it drops it into a holding box, and then it carts that holding box over to another function and dumps it out into another holding box, and then in that function it works with it. At no point do we know the contents of enemy 1, nor do we need to. Our lives just got easier. Alright. Master of Names, Lowly Kithman, Closing Distance, Mayhem of Munchkins, the final Kith Maze. The final Kith Maze is still loops, but it's more complex loops. It's also not opening. There we go. Sometimes I have to click the play button twice. Yeah, it's kind of irritating. It's still a loop, though, through and through. It's just a prime example of having to imagine code structure in your head and anticipate future events and things like that. Because that's what this is all about. This is us trying to figure out what is the most efficient, repeatable pattern that we can use. So in order to do that, we have to think about how the entire pattern is going to play out in our heads. Imagine where we start, imagine where we end, and if where we end can be where we start on the next one. And this is a prime example of programming, and that's why I bring it up, like the mindset that you have with programming. I mean, all of these have been examples of programming, but of the mindset that you have while you're programming. When I say, like, you've got to keep moving parts in your head and figuring out, you know, what goes where and the order of certain things, this is a fantastic example of it. Because it's all about anticipating when you're supposed to be doing certain things and making sure that everything that you've imagined in your head works out in practice, which, I'll be honest with you, 90% of the time, it's not going to be the case. That is okay. Because the nice thing about coding is you can always just write new lines or delete old ones. And that's it. So I'm going to move on to the second world. Not in the interest of leaving you guys behind necessarily. Like I've said before, if you have questions about any of the levels, if you feel like you're stuck on anything, if something doesn't make sense to you, do not hesitate to mention it in the question box. I will stop what I'm doing, help you out, or at least I'll say, you know, I'll get right to it. Help you out though, and we'll work through it. So, like I said, me moving on is not me, leaving you in the dust or anything like that. Don't feel like you're being left behind. It's just I want to make sure that I cover a few different topics today. Alright, so we've got the defensive Plainswood, winding trail. Oh man, we got a bunch of things. Let me think about... Alright. Basic syntax, arguments, and strings. Aha! If statements. Just go ahead and make sure this is in Python. And we'll get the code up and running before I start explaining them. Word of warning, if you've used CodeCombat before in JavaScript, like anybody who was in Young Engineers in the spring semester, you are going to have to go through all of the levels that you completed in JavaScript, change hero, change language to JavaScript, or sorry, Python, on every single level that you've completed. And it, you should be working on whatever um, whatever levels you haven't completed yet in Python. Um, so, if you're still, like, if you're working on Kithgard Dungeon, then continue working on Kithgard Dungeon. If you've made it out of Kithgard Dungeon and you're now in the forest, then, continue working in the forest. If you've made it to the third world because you just, like, really love programming and you got through it in 2 days, then go ahead and do that. Just as long as it's in Python, it's wherever you are with Python. So that is to say, if you've completed other levels in JavaScript, you should probably go back and redo them in Python, because Python has different syntax. But good question. Since I know you've done at least a few of the levels in JavaScript. Alright, and it's going to yell at me for a bit because this is still in JavaScript, and you have to manually change the code over to Python. Okay, so this should run. Oh, right. Python needs to have colons. Alright, let's try that again. Perfect. Okay, so what did I just do here? What happened? What? Well, I'll tell you. You'll notice these statements right here. If, and then things in parentheses. You notice there's a space. I should have clarified. If there is no space, let me. Come on, come on. Oh dear. Oh wait, no, I can do this. Here we go. Perfect. Let's do a new one. No, I don't want to save this. Alright, so honk horn, the old standby example. Parentheses. That's how we know it's a method, right? Keep in mind, there is no space. No space. You type it, immediately parentheses. No space in between.
Caution.
If you have an if with a space and then parentheses, well, that is an if statement. If statements are what are part of something that's called control flow or control statements. Basically, everything that you've created thus far doesn't really react to the outside world. That is to say, if you run the code once, you'll get a result. You run the code again, you'll get the same result. You run the code a third time, you'll get the same result again. The code will follow the same instructions. It will do the same things. There is no variance. If you run it 1, a million, 100 million, an infinite number of times, it'll always, just continually run the same sort of order commands and set and everything like that. Dutifully, mind you. I mean, computers are nothing if they're not dutiful. Or dutiful. But there's no variance in it. There's no sort of rudimentary decision making on the computer's part. Um, you know, what if you wanted to have your hero go up instead of down, and you wanted to change the course of the game that way? You know, whatever. Enter control flow statements. Control statements. Most basic of which is the if statement. So if statement. Notice that statement is in parentheses. Most of the time, you'll not be writing the word statement literally in between the parentheses. You'll be writing something, like maybe a math equation or whatever. Point being, you'll have this, you'll have, your colon, and then you'll have code down here. Remember, indented code, which means it's a part of this if statement. If this statement is true, then this code executes. If, on the other hand, this statement is false, this code gets skipped, and you move to whatever is after, the if statement. Now there's an important distinction to make. If the if statement is true, then this code still gets run after the if statement. It's just so does the if statement. It's only when it's false does it really change a whole lot. So this if statement would then not execute and you'd skip on to the next thing. So this allows you to have some variance in your code. So like let's say you had if calculator add. And then down here you had quit. So now you have an if statement here. If whatever program we're running is a calculator, then go ahead and run the add function. This statement's sort of asinine because I mean, it doesn't really make any sense, but in the sense that, if calculator is true, then run add. Then go to quit. If calculator is not true, skip add, go straight to quit. Now, it should also be mentioned that if statements can be chained. So we've got if statement 1 up here with some code. We've got if statement 2 with some code. Whoa. We've got if statement 3 with some code. And you get the point. So now if statement 1 is true, run if statement 1's code. Then check if statement 2. If that's true, then run its code. Then check 3. If that's true, run its code. If any of these are false, skip and go to the next one. So let's say 1 is false. Skip 1's code, go to 2. If 2 is false, skip 2's code, go to 3. But you can chain them in order like that. You can also nest them, but that's later on, and that also tends to get fairly messy to look at, so it tends to be better to modularize your code more than that. But sometimes that's an unavoidable thing. Anyway, so these can be chained, and then there's one more statement for now. That's good to know. Else. And code. Else is a catch-all statement in case all of your previous ifs were false. So if 1, 2, and 3 all three of them turned out to be false, You run the else, no matter what the situation is. It could be that there are only 3 situations in which any one of these is true, and then there are a bazillion others in which none of them are true. In those bazillion other situations, all 3 of these are skipped and the else is run. Else is not picky. Else will take anything that any of these if statements don't want, happily, and then run the code. So for instance, let's say you had a bunch of if statements. Let's say if rainy, if sunny, if snowing, and if hot. So in, the if rainy statement, let's think of this as a series of if statements for you getting ready to go outside for the day. So if rainy, you probably want to grab an umbrella. If it's sunny, you'll probably want sunglasses. If it's snowing, you'll probably want snowshoes or boots or something like that. If it's hot, you probably want sunscreen. Although sunscreen doesn't really protect you from hotness, more protects you from sunniness. But it's just for argument's sake. So if it's rainy, you need an umbrella. If it's sunny, you need sunglasses. If it's snowing, you need snowshoes. If it's hot, you need sunscreen. Let's say it's nighttime. Well, that's a problem. Unless there's an else in here. And in the else situation, you put on pants. So you put on pants when it's nighttime. The problem with this code here is that the only situation in which you're putting on pants is if none of these are true. But let's ignore the hypothetical situation, which leaves people walking out of the door pantsless like 90% of the time. And then just from a coding standpoint, take a look at this. So I should say there are a lot of situations in which, you'd be walking out with pants on. If it was a cloudy day, because it's not raining, it's not sunny, it's not snowing, and it's probably not hot. Or if it's just a cold, kind of dreary day, well, that would be the same thing as cloudy. Or nighttime, or I'm trying to think of a situation in which none of these are true. I think I covered my bases decently well. Unfortunately. So there are a decent amount of situations in which this hypothetical person would be walking out of the door with no pants on. Anyway, else is a catch-all statement if none of the ifs turn out to be true. Now, multiple ifs can turn out to be true, so it can be sunny and hot, so you grab sunglasses and sunscreen. It can be rainy and sunny, so you grab an umbrella and sunglasses. Or it can be sunny and snowing, sunglasses and snowshoes. Because these if statements aren't necessarily mutually exclusive from one another. It'll check each one of these, like I did in the previous example over here, to make sure it's true. If they are true, though, then the else is skipped. The else is only run if none of the ifs are true. So what about what goes inside those parentheses? Well, now you've got logic operands. So this is the kind of stuff that you can use in a computer to check and make sure something's true. So you've got the greater than, you've got the less than, you've got the equal to, is equal to, you've got the is not equal to, and you got the variance on the greater than and the less than. You got the greater than or equal to, and the less than or equal to. The reason why it's 2 equal signs is in order to differentiate itself from a single equal sign. If it's a single equal sign, you just say x is equal to 6. And this is not checking whether or not it's true. This is a command. It will put 6 into x. x double equals 6, in this case, the computer will ask itself, does x equal 6? Does it equal 6, as opposed to x does equal 6 now. So that's an important distinction to make, because I'm sure you'll run into a situation later on where you're like, why is this always running? And then you'll go, oh, I only put one exclamation or one equal sign in there because I am, I've been coding for 3 hours and my brain is starting to turn to mush. And, I just need to like stand up and start looking at other stuff for a minute and take a break. That kind of a thing. But the way these work is they check. And if they make sense, then it's true. What do I mean by that? Okay, so let's say 6 is greater than 9. Is that true? Well, no. So this statement would evaluate to false. What about 9 is greater than 6? Yes, that would evaluate to true. If you put 9 is greater than 6 in here, that if statement would automatically be true. Because it's asking itself, okay, does that make mathematical sense? Yes, it is true. Is 5 equal to 5? Then yes, it is true. This one is not equal. So we could say 6 is not equal to 5. And that is true. 6 is not equal to 6. That's false. And then you've got greater than or equal to, or less than or equal to. So you can say 6 is greater than or equal to 4. You can also say that 6 is greater than or equal to 6. Both of these are okay, because it's greater than or equal to. 6 is greater than 4, and 6 is equal to 6. No big deal. Those are okay. Same deal with less than. 4 less than or equal to 6. 6 less than or equal to 6. Those are both true. But the real messy thing, or the real power of these, I should say, which is not at all related to the messy thing of this, that was the first thing that popped in my head, is you can use these with variables. So you can say if hero health is greater than 0, then Heor is alive. Boom. So as long as this statement is true, if hero health is greater than 0, then the hero is alive. As soon as the hero health equals 0 or drops below 0, well, the hero is no longer alive. It's a bit of a morbid example, but it's one, that you can think of in your head easily. If hero health is greater than 0, then hero is alive. If this statement is true, and hero health in this case is a variable, so we can use variables. If hero health is greater than 0, then hero is alive. Simple as that. If, let's see here, if wheels does not equal 4, then can't drive. So if you don't have 4 wheels on your car, then you can't drive. This isn't exactly a perfect example. A, there are motorcycles. B, wheels not equal to 4. You could have 1, 2, or 3 wheels, or you could somehow have 5, 6, 7, 8, 9, 10, 100,000 wheels. So generally, in this case, you might want to check and make sure that it's, like maybe less than 4. And set it up so it's not possible to have more than 4 wheels. But anyway, that's the idea. These if statements, yeah, 18-wheeler, there you go. These if statements allow you to change the flow of your code using these conditional operators over here. Let's go ahead and write these back in. And, you know, they allow you to have some variance in your code. Real quick, I'm just going to go ahead and do like a simple little quiz. I'm going to write something up here. I'm going to have you guys, actually I'm just going to type it because I want you guys to be able to read it. I'm going to type something up here, and then you guys just throw into the question box whether or not the statement will evaluate to be true or false. True or false? Yeah. Exactly. Nice and easy, right? How about aha. See? This is messing with your head. Maybe just you don't see the negative here. -1 is not equal to 1. That statement is true. That's what I was saying before. The exclamation mark and equal sign is not equal to. But yeah, that's why it's generally good to sort of, oh yeah, no worries. That's why it's generally good to kind of look at this stuff, because this statement is true even if they're not equal to each other. But that's what we're looking for. We want to make sure that they're not equal to each other. So let's do how about that one? Yeah, yeah. Back to basics, right? Now here's one. This one's a bit of a trick question because I have not gone over this one with you yet. But there should be a clue as to what it means with one of the other operands. Yeah, exactly. This is the last operand, and it's simply called, well, there are other ones which we'll get into, but for now, this is the last operand we're going to go over today, and it's simply called not. Just exclamation mark is not. So this can be read as not true, which is false. The if statement will be read as false. Those start to get a little bit weirder. We'll probably, oh, maybe, I don't know. The next week or so is kind of in flux, but we will maybe spend next week continuing along Python sans Raspberry Pi. Really, it's anyone's guess at this point. And if that's the case, we'll spend some more time going over operators and truth tables and stuff like that. And then things really start to mess with your head, and that can be fun. All right, so it's 8:56. I'm going to do the poll questions, and then we'll leave it open to questions like we always do. And if you don't have any, you're welcome to head out and have a wonderful weekend.